Well, good afternoon, everybody, and thank you for joining us for this panel session on clean water for all, not a drop too soon. I'm Carol Champion. I'm with the Ontario Centres of Excellence, and I'd like to welcome you to this session. I'd like to remind you that if you're tweeting today's session, please use hashtag OCE Discovery. It's my pleasure to introduce you to our moderator for this session, Brent Wooten. And Brent is the interim CEO at WaterTap. And Brent has been involved with WaterTap right from the start. He was on the board of WaterTap. But prior to his role as interim CEO, he'd already joined WaterTap as the Vice President of Policy and Exports. Brent was Director and Senior Scientist at the Centre for Alternative Wastewater Treatment at Fleming College. And as an international polar year researcher, he's been conducting research on sanitation in northern communities for the last 9 years. And he's engaged in research and demonstration projects across Canada and internationally in China, India, and Kenya. Brent.
Thanks, Carol. Good afternoon, ladies and gentlemen. I'm Brent Wooten. I'm delighted to welcome you to this panel discussion today. This session will look at how access to clean water and sanitation are some of the world's most pressing challenges, especially challenging for developing countries. With its unparalleled access to clean water, Ontario has become a global hub for water technology innovation. From wastewater treatment to water recovery, reuse, Ontario is known around the world as a place to come to for expertise in water treatment especially. Our discussion will include challenges posed by things like the drought in California, water scarcity, while keeping economic and environmental sustainability front of mind. Before we begin, I'm going to introduce our illustrious panelists. For their full you're illustrious to me. For their full biographies, you can look at the mobile Discovery app, which I've figured out how to use. So I think everybody else can if I can. First, we have John Coburn. He's managing director at XPV Capital. John was one of the earliest employees of Xenon Environmental. As president and chief operating officer, he helped grow the company from a startup to over 146 million in revenue, with a final market capitalization, I think, of over 700 million. Upon leaving Xenon, he was awarded the Architect of Xenon Award, recognizing his efforts to build the company into a world leader in water treatment. Xenon was acquired by GE in 2006, and then since then he's been managing things at XPV Capital. Our second panelist is Dr. Yuling Chen, Director of the Center for Global Engineering and Professor of Chemical Engineering at the University of Toronto. Her educational background is in chemical engineering. She has degrees from MIT and a PhD from Stanford. The last 6 years or so, she's focused on research and teaching interests on global engineering, a founding director of the Center for Global Engineering. And one of her recent projects was reinventing the toilet, of which I believe she was a runner-up, and she can tell you more about that award. Our third panelist is Adam Doran, VP of Marketing and Sales with Aclaris. Adam has worked with his cousin Mike on research development, commercialization of their ozone systems for water, wastewater, and soil remediation. They formed Aclaris after partnering with investors a few years ago. Adam spearheaded the company's sales and marketing strategy, translating technical data into effective campaigns. And I've had the privilege of working with Adam in some R&D activities. Our next panelist is Irene Hassas. She's Director of Strategic Partnerships and Government Relations at Newterra. Irene directs the development of strategic partnerships at regional, national, and international levels with government and non-governmental organizations, as well as different stakeholders in industrial, legal, consulting, and research firms. She has international experience in the area of business development in different jurisdictions, including the US, Latin America, Southeast Asia, the Middle East, and South Africa. Finally, our fifth panelist is Wilf Steffen. He is CTO and VP of Engineering at Clearford Systems. Prior to his current position at Clearford, Wilf worked for a wastewater treatment equipment manufacturer in a number of roles, including sales, operations management, and president of designing, fabricating, and installing equipment, both in Canada and internationally. Wilf has international experience in West and South Africa, where he lived and worked for an oilfield service provider early in his career. Fantastic panelists. I'm so pleased you all could make it and join us for this discussion today. Each panelist is going to give about a 5 or 6 minute presentation, and I'm going to ask that you hold questions until all the panelists are done, and then we'll do a Q&A session which I will lead, and I have my own questions, and then we'll open the floor to questions. Thanks very much. First off, we have John.
Thanks, Brent. Good afternoon, everybody. Nice to be here. See a lot of people that come out of my past. I'm a chemist, long ago, University of Waterloo. I got really lucky and landed a technical job at Canada Centre for Inland Waters, and for 10 years got to play with all the most advanced toys in the world. We called it all the boys and all their toys. GCMS, MSMS, LCMS, ultra-trace organic contaminants, you name it, we studied it. We tried to develop methods to detect it, analyze it, determine its fate in sewage treatment plants, in water treatment plants. As a technical foundation, unbelievable. At about that 10-year mark, I ran into a guy named Andrew Benedek, who was leaving a professorship at McMaster, still probably had 20 grad students, wanted to start a company to solve the world's water problems, really before the world knew it had water problems. And I got really excited about moving from studying problems to actually solving problems. So we had a really simple concept. We need to have a great lab to understand what the problems are, what the contaminants of concern are. We had a great process engineering group to assess the options to treat or destroy or recover. And then we built a systems business to actually deliver the solutions into industrial and subsequently into municipal applications. That was a 20-year lessons learned experience. How to build companies. We had 14 companies around the world, and how not to build companies, because I think we made just about every mistake possible and survived, which was the good part. And we really took membrane technology in both water and wastewater treatment to really core, rapidly growing technologies, membrane bio, replacing clarifiers with membrane technology, producing very high quality effluent, suitable for recycle, which was in advance of the real demand for driving recycle, reuse. Today, North America still uses or does about 4% recycle. Australia now, with their drought issues, there's now over 30% recycle. Israel is something over 70% recycle. So the pathway for all of us, according to the WHO, we're headed for something like 70% of the Earth's population living in water scarcity by 2030. So think about it. Today that number's about 20 to 24%, and we're going to triple it, living in water scarcity. The first time I started to travel into the Middle East and other exotic locations, finding that, today's not our day for water, was a shock. Because here in Canada, we always have water, right? Well, again, if we take it for granted, we're not. And lots of the world doesn't have water every day. They might get it every other day, every third day. You get to fill a cistern, and that's your allocation. So that started to really open my mind to, the third phase of my career, which is with my partners David and Khalil at XPV Capital. How do we invest and create 10 more xenons, or help create them? Because really, it's the entrepreneurs who have to make it happen, and we have to stimulate it, we have to support it, we have to mentor it, we have to share the scar tissue, and that's really what we're all about, trying to find great opportunities like Nuterra and Filterbox and BCR and US Water Filters and Fathom and lots of interesting companies in the water space that are necessary to deliver that next generation, smart water, more effective, sustainable uses of water, and obviously reuse and recycle. And the same goes on the materials in the waste. We have to stop using something once and throwing it away. All of these things we characterize as sustainable. They are economic drivers. We have to deliver economic drivers. Today still, we will not find customers willing to pay to kiss a frog or hug a tree. They don't do that. They need the economic motivation, and really that's what we're here to try and find, are the companies that have the technologies and really are working to bring the next gen solutions right across the board. So we've got 2 funds. We're closed on the first fund. We invested in 8 companies. It was $150 million US, still have reserves to carry on. The second fund was closed last year, and we'll do 12 companies, and out of that we'll spend $250 million and hopefully deliver economic returns to our investors. Thank you.
Yeah, go ahead. Thanks, John. Next we have Dr. Yulin Chen, who's going to talk to us about her work.
Thank you. So I'm going to talk to you a little bit today about our experiences working on developing water and sanitation solutions, technological solutions for the developing world. And so the global need for sanitation and clean water is just absolutely enormous. 2.6 billion people in the world don't have access to basic sanitation. 1 billion people don't have access to clean, drinkable water. Okay? And the health impacts of these two statements are just incredibly massive. About 3.5 years ago, Bill Gates himself launched what he called Toilet 2.0, reinventing the toilet challenge. It's a really interesting concept for how to get technical innovations started in this field, which for the most part has been largely ignored. So there are a lot of social entrepreneurship solutions, implementation solutions, total community sanitation movements, and so forth, but not that much technical innovation. So we were one of 23 engineering schools around the world who were invited to submit a proposal to come up with a new idea for how to deal with sanitation waste for the developing world. And we were one of 8 teams that were funded in that first round, and there have been 2 additional rounds since then. But the challenge posed to us was incredibly difficult, very, very ambitious. We were to come up with a household scale solution for sanitation that would process the human waste, sanitize the human waste within 24 hours. So the waste doesn't sit in a pit latrine to accumulate, get abandoned, get overflows if flooding happens, and so forth. It has to be off grid, so no grid electricity, no running water, and no sewage plumbing, because that's a condition that those 2.6 billion people live in. It has to be very, very low cost, less than 5 cents per person per day, including the operating costs and the amortized capital cost, which seems incredibly challenging. But I would just tell you that for the investors among you, 2.6 billion people at that cost target is a $47 billion a year market. Okay? So there's market at the base of the pyramid. Okay? And no added chemicals, no consumables, has to be very easy to maintain given the skill set of the setting. So extremely challenging. Okay? So that we started our project in August of 2011. So it's now 3.5 years. And it's been a really interesting journey. 6 minutes isn't long enough to talk to you about the details of the technical innovations. But working with the Gates Foundation is a unique experience. They give you a lot of funding, but they give you a very short time frame to work on things. What I often say is funding divided by time is work intensity. And it's been pretty intense. And so we're now in phase 3, but at the end of each phase, phase 1 and phase 2, it's been punctuated by toilet fairs, which people usually laugh about. They don't understand what that means. But the very first toilet fair was in Seattle a year after we started. We did well enough to get funded for a second round. Second toilet fair was in India just about a year ago. And for the second, phase 1 was just proof of concept. Phase 2, we delivered a fully integrated prototype. It actually worked. Okay? But if you look at the picture in this, I was almost embarrassed to show it because it was too big, it looked too expensive, but that's a snapshot in time in terms of our development. But again, we did well enough that we got funded for a third round. And the next goal, so I show 2 pictures here. We've gone from something that looked really, really large to something that's a lot smaller now. That's just one component, but it's a lot smaller now. I can see our way to getting something to a prototype when packaged properly will be on the order of 3 feet by 3 feet by 3 feet. Okay? And so our goal in phase 3 is to get to a commercialization ready or pre-commercialization prototype by the time of the next toilet fair, which right now is tentatively scheduled for about a year from now. Okay? And our focus is very much on simplifying the process, making it more and more robust, making it smaller and smaller, and improving the energy efficiency. If all this works, what we'll have is this 3 by 3 by 3 system that will have all the solid pathogens destroyed, the solid waste destroyed, and the water that has been disinfected enough so that it's clean enough to be discharged. And the extra energy requirement that can be supplied by something like a solar panel, the only requirement will be on the order of less than 10 watts on average. Okay? So it's becoming a very feasible process, and the cost target, we're also getting very close to that as well. Okay? So that's one project, but I'll just talk to you a little bit also about wastewater wastewater from industrial processes or factories in a developing country. This is a project that I'm just starting now, getting involved with the textile industry problem in Bangladesh. This is a 1 trillion tons per year problem. Industrial waste from textile factories. Lots and lots of non-compliant factories, even though regulations exist. And there are so many opportunities here. So very low-hanging fruit, I think, that where you can improve this, and a lot of this 1 trillion tons is just discharge into drinking water sources. Let me show you a picture. Okay? So a river right next to one of the factories is completely black. This is what the discharge water looks like. So my very simple take-home message is that there are enormous challenges and opportunities that require, in some ways, rethinking the technology to make it appropriate for that setting, not just particularly in terms of cost, but also many other factors as well.
Thank you, Dr. Chen. I want to ask, do you have a prototype of that toilet at U of T? So if I come visit you, can I try it out? Is it?
By August, we'll have some.
By August, okay. I'll hold it till then. Next up, we have Adam Duran from Aclaris.
Good afternoon, everyone. Thank you so much for coming out today and listening to us speak. And I'm quite humbled to be speaking here with such an elite panel. We're a bit newer in the game, that's for sure. I'm actually, Claris manufactures ozone water and wastewater treatment systems, from residential systems for individual cottages to agricultural to industrial to commercial. We're actually a product of the OCE, I'm very happy to say. I don't know if I'd be standing here today, and it's not because I'm kind of kissing butt here because OCE is here, but we came back from Alberta with a turnkey ozone system technology that my cousin and myself helped develop for water, wastewater, and soil remediation. But we got stabbed in the back a little bit in Alberta, came back to Ontario wondering how are we going to find the right partners. We don't want to let this technology go. It's great, but how do we make it work? And the innovation cluster at Trent University is funded by OCE. And within days of meeting the innovation cluster, we were introduced to our partners. We went through a bit of a Dragon's Den style of negotiations as well as benchmark testing. And then 3 years later, we've come quite a long way. So very happy to be speaking here today, especially where we've come from. Now, our Claris systems are very unique in the space. We're a much smaller ozone size of system. We go for, the 5 to 500 gallon a minute range of systems. But the units are not only applicable here for everyday users, for industry, they're extremely low maintenance, they're long life, they're easy to use, and there's no consumables. So in the last 3 years, we went from commercialization to definitely to market. So we now have dealerships across the country, dealing everything from residential systems to agricultural. We work with parks, Ontario Parks, and the Ministry of Natural Resources. We have 2 park systems out now, and a third one this year. The big advantage for them, obviously, with ozone, and I will speak of ozone and what it is for those that aren't familiar in a minute, but basically we're able to provide a really small turnkey system that was easy to operate, which is important for them, given that it's run by students quite often. But the difference for them was they didn't have to build a large cistern for their chlorine contact time, which saved about $1 million. Plus, they're able to cut their costs over 20 years significantly. So just an example of who we work with. So we also work with food companies, fish companies, industrial companies. Ozone's made on site, there's no consumables, so people are using it for clean in place systems, for washing their products, and for eliminating a lot of ongoing costs that they normally incur. We just finished a landmark study with ozone in regards to its work on emerging contaminants of concern. That would be your pesticides, medications, hormones, and chemicals that are in trace amounts in the drinking water and wastewater. So we had a 97% removal rate with that pilot test. Plus, we had superior disinfection to the UV system that was in place in that city. And as well, we had much less ongoing costs, which is speaking exactly what we're talking to today about practical applications. Our systems are very unique. We're able to scale them up. They're modular in design. So the same system we use for a cottage owner, you can use for commercial, industrial, and the like. But how ozone works, you make it from the air, you dry it, you either use an oxygen concentrator or not. Now, we have a minimal moving parts system, so we make ozone easier and we use it better. So we keep our costs really low. The systems themselves are quick to maintain if you do need to. If you do need to make any changes, it's a quick change. But why ozone is so effective? It's all natural, which is always important. It's nice that we can make it right on site, so you don't have to haul in consumables. It's not hard to find. We use low watt electricity and air to make the systems. It's 3,000 times faster than chlorine, and 300 times stronger, but it breaks down to oxygen when it's done. So, ozone's been around a long time. It just necessarily hasn't had the most practical systems. They've usually been limited to municipal treatment, industrial, and actually 95% of bottled water, which uses ozone. Ozone's O3, 3 atoms of oxygen, and essentially it'll do disinfection. As I said, it's much faster than chlorine. Even our household systems are able to provide log2 crypto removal, which is typically quite difficult on flow and on demand. So the systems work without loading, without consumables, without heavy maintenance, and they work on demand, which is always nice. Beyond disinfection, which ozone is well known for, it's also a really powerful oxidant. So it's able to pull out high amounts of iron or sulfur, manganese, that sort of thing. And the groundbreaking study with McGill is a big plus. We see that as critical moving forward to remove those emerging contaminants of concern. And beyond obviously the contamination, ozone does a great job in the aesthetic side. So we improve the color, the taste, the smell of the water, so that you actually want to drink it. It's not just safe to drink, but aesthetically pleasing. So practically our systems, I've seen them at cottage units pulling out of lake water or even wastewater and removing the bacteria, tannins, color, taste, and smell, and looking like bottled water at the end. So we're NSF 61 approved and Canadian built, and we've just begun export. We've started exporting to Australia, as well as we're looking at the US, trying to find the right partner. Export's not always as simplistic and straightforward as you might imagine. It has to be done right, and we're doing it right now, and we're building quite slowly and appropriately. Basically, we're in a niche market in Canada, but we see our system applicable across the world, from small decentralized systems that offer a practical design that's simplistic, that can work without heavy knowledge. You don't have to be a level 900 operator to make these systems work. They're quite easy to install and operate, and they last a really long time. So with my background in international development, that's definitely where we're moving forward now that we've established ourselves in Canada. So, it's a great opportunity for microfinance, self-run systems that don't need a lot of heavy maintenance and upkeep, and are applicable across the world. So that's sort of my 6 minutes. I'm happy to answer questions later. I'm probably glazed over half the stuff I want to talk about, but thanks very much.
Thanks, Adam. Next, we have Irene Hassas, who is going to talk to us about Nuterra.
Hello, everyone. I wish there was a magic pill. This is Discovery Conference. I really need that magic pill to make me feel better because I'm battling with this cold and I may lose my voice, so I apologize. First of all, thanks to OCE today for putting this interesting panel together and also for inviting me to share an interesting story about Nuterra's growth and innovation in Ontario. Obviously, another growing company in Ontario, and XPV is one of our investors, so really exciting time for Nuterra. You have already heard interesting views from panelists today, initially, I was going to share some statistics with you on water scarcity, polluted rivers and lakes, health issues related to contaminated drinking water. But I think you can Google anything you want these days. And the question is, once we get all this data, how we convert this data into useful information so we can put the right actions together, put the right programs together so that we can adopt the right technology so that we can develop sustainable communities and eventually sustainable economies. And as much as there are a lot of bad news out there and always, anything bad makes the news, obviously, I think from the business point of view and from the economic development point of view and helping communities around the world, this is actually the most exciting time to be in water sector. And despite the fact that you hear all these news about the market changes, the oil and gas prices, and a lot of issues with political instability, I think not very many projects are being invested in, the large projects that we need them, especially in oil and gas market, in mining, in municipal. But the fact that World Economic Forum ranked water as the first sort of water crisis as the first top risk identified among the 10 risks around the world, and that was identified by 900 leaders in the Economic Forum. That's amazing. So that's why I think it's the most exciting time to be in water sector. And also climate change is another one. As you know, that was also on top of the list, and from the impact that it can have on our water resources, on our utilities, aging infrastructure, flooding issues, and many things that we may experience down the road. So I don't have any doubt that there will be an interesting trend in the market with regards to investment and new innovative approaches to address many of these issues. But it has to be innovative. So when we look at, especially when we look at, the Ontario-based company or any company out of this province that want to look into those big opportunities, and necessarily not all of them are in North America, there are a lot of parameters that need to be taken into consideration. The social, the cultural, the financial, the way business happens in other parts of the world. And the only way an Ontario-based company can be successful in other markets, and especially in these emerging markets, is only when they recognize the human capital requirement, the time which is a critical resource for an SME, the financial requirement. And no matter how sophisticated and interesting the technologies are, necessarily they may not work in other jurisdictions. And they got to be, as much as they're standard and interesting, they got to be strategically customized to work in other regions. And innovation is not just in the products. Innovation should be in financing models, innovation is in different business models, and innovation should be in even operation and maintenance, which is something that Newterra has experienced over the past couple of decades. So with that, question is, who is Newterra, and how we got to where we are today? So 20 years of operation. I've been with the company for 12 years. I have seen the company to grow from like 5 or 6 people to 230, 40 people now. I have seen a small assembly shop in Toronto to now 170,000 square feet of manufacturing. So a lot of interesting changes. It hasn't been easy. And the growth has happened through both organic and inorganic growth. I mean, we had to do some acquisition in order to have access to other geographical area, to have access to new markets, to have access to new technologies, and definitely putting the right team, right culture, right innovative solutions, and continuous innovation brought us to this level. So we manufacture a membrane in Germany, we bring it to Ontario, we put the rest of the package together in our 100,000 square feet of manufacturing here in Ontario, and these are modular and decentralized systems that provide clean water to clean drinking water and also treat sewage, and we also address some of the industrial water issues, municipal issues, and many other areas. So we play in different markets. We obviously North America, and then we have systems in Africa. We have systems in South America. We are looking at opportunities in Middle East, and with that, I would like to share. And just before I go back, so here it shows you. How we use our membrane-based technologies to take the gray water or black water and use it for different purposes. Especially, the reuse is the biggest aspect of our treatment system, whether it's irrigation, putting back in, different industrial applications, or flushing toilets, etc. So I got a couple of examples for you here. This is a system in Africa, in Zambia. It's 26 containers. It's sewage in, raw sewage in, clean water out, and it's accommodating the sewage of about 8,000 to 10,000 people. It's a community, but basically it's a camp where people are living, and they had an issue with water, with the sewage obviously contaminating a nearby river, where it was the source of drinking water for the community. And definitely this system is addressing that issue. The next picture is a system in Chile. Lots of challenges, obviously, when you deal with different altitude and mobilization of these equipments at the site. So again, that's another part of the innovation you have to think about when you design your systems. And the last picture is our installation in Northwest Territory in Canada. We have many installations in that part of Canada. And when you think about it, it's like minus 50, 60 degrees. And when you think about the operation, the maintenance of this system, the broken pipe in the middle of the night when it's minus 60 degrees, how to clean tanks and things like that, those are all big challenges. And as much as they may not seem to be that important, those are big part of our innovation that happened over the past couple of decades. And I think what brought us to this level was obviously thinking about the hot climate, cold climate, altitude. But at the end of the day, these prepackaged systems, the modular, the decentralized design, and continuous innovation brought us to where we are today. So with that, that's Brent.
Thanks, Irene. Next we have Wilf Steffen from Clearford.
Thank
Thank you for inviting me. I want to talk about two innovations that we have. One is technical innovation and the other is a financial innovation. And they're both around the same theme of thinking about the entire problem, not just one part of the problem in isolation. So the first part is you have to think about the water solution in tandem with the wastewater solution. And then the second innovation we'll talk about is a financial innovation related to also thinking about the entire problem. So what we've seen in tropical countries is the solving the potable water problem is fairly easy to do. This is an example where several water meters are installed right in the street, and then they just grout them into the concrete, and they don't have to worry about frost or snow plowing or any of those issues we have here. And then often they can retrofit the systems for drinking water quite quickly and at low cost. It's a bit untidy, but as you can see, they can provide water fairly easily and at a low cost. Here's another example where the water pipes are running along the side of those buildings, and so, as I say, it can be done at a low cost and fairly quickly. Unfortunately, the problem is that adding more potable water to an environment that doesn't have adequate sanitation or wastewater just makes the wastewater problem bigger. And this is a river in a suburb of Manila, and so as you can see, all of the waste from all of these homes are flowing down this river. Another thing that we've seen is adding toilets into an environment where you don't consider the wastewater component also can lead to problems. So many people don't want a toilet in their home. So this is why this is an outdoor type of toilet. You can see this is a sort of a deluxe one. There's a water tank on the top. There's hand washing sink there. This is an example of maybe a multi-family outdoor toilet. But the problem is, in the rural environment, if you don't think about the wastewater part of it, this is a breakout and there's all the contaminated water flowing out in the open. In the urban setting, the problem is a little bit different. Maybe the local authorities are charged with designing sewage collection system that's designed for the supply of 135 liters per person per day of water. But they can only provide half or 2/3 of that. So the resulting problem is that you don't get the cleansing velocities that you need to keep the pipes clean, and you end up with clogged sewers. And unfortunately, the areas that are least equipped to provide adequate water are areas least equipped to do proper maintenance. So this is an example of unfortunately how things have to be handled, that manual methods of cleaning out these clogged sewers have to be used. So here's our technical solution and our technical innovation. Typical wastewater collection is done in two parts. Is that there's a conventional pipe network and then a treatment plant or a treatment technology at the tail end. Clearford has a 3-step process. We have a digester tank outside of each home or apartment, and in that tank you get settling of the solids and some biological treatment done. That allows for a more flexible pipe to be used, lower flow rate. We're only flowing the liquid fraction of the waste, and so it allows us to use a different type of pipe. And then the third part is the treatment technology, and we use different technologies depending on what is most appropriate for the environment. And so here's an example picture. You can see a tank outside of each home, connects to a collection network, and then onto a treatment plant. An installation that we did in near Bogota, Colombia, used rainwater harvesting as the source of potable water. We cleaned that water and distributed it throughout the subdivision. We used a Clearford 1 collection system. We used a constructed wetland as the wastewater treatment technology, and then we reused that wastewater for toilet flushing and irrigation. So here's the start of the cycle, rainwater collection pond. You can see one of the tanks there in the foreground. Because we can use flexible pipes, you can see we were able to keep certain features of the environment there. We didn't have to just go in a straight line. We could curve around those trees. You can use common pipes in a trench when you have pipes that don't leak. So in this system, we've got our potable water and the reuse and the sewage all together. And then here's the constructed wetland. And that's at the end of the cycle. And as more homes get built, we will install larger and larger wetland to accommodate that. Now, the second innovation we have is a financial innovation. And this is one we're using in Ontario. And we call it pay for performance, P4P, and that separates it from triple P, which people are familiar with. In triple P, the municipality has some debt involved. In this system that we've created with our investors, there's a $100 million fund created. No capital is invested by the municipality, and we do the design, build, and operate the system completely, and the municipality only pays when the system is operational. And so all operating costs and maintenance costs are the responsibility of the corporation, and the monthly fees pay for all the O&M and the capital cost. And then the system is transferred after the 20 or 30-year contract term. And so, as I say, Clifford has two innovations. One is the technical innovation, and just you need to think about the water and wastewater components together. And then the financial innovation is to ensure that the system can be installed. So, thank you.
Thanks, Stefan. And thanks to all the panelists for those excellent presentations. I'm going to ask a few questions now of my own, and then I'll open it to the floor for Q&A. So my first question would be, what do innovative solutions for the global water challenge look like? And let me just qualify that a little bit more. We hear the word innovation a lot, especially at this event. So I guess I'm asking you all, what does it look like for these global challenges that we've heard about from your perspective? So I'll start with you, John. And your mic should come on, right? Yeah.
We'll see. It works.
It works.
Success. For us, I think I mentioned that nobody's willing to pay to kiss a frog or hug a tree. So everything has to be driven by economics. And all of the innovation is either going to be delivering around increasing scarcity or deteriorating quality. And those solutions need to be more economically sustainable, meaning less energy, less chemical, less water, less labor, less system, less membrane replacement cost. All of those economic drivers need to be tackled and driven down to deliver a better economic solution through better technology.
Great. Dr. Chen?
I'll say some of the same things. I think, first of all, innovation is not the same as invention. You can invent anything in your garage or in your lab without thinking about whether it's going to be used. But I'm interested in having what I work on eventually get used for the target population that I have in mind. And so I need to understand the mindset and the everyday realities of my end consumers. Whether that consumer is a $1.25 farmer living somewhere in the village in Bangladesh, or a textile factory owner somewhere in Dhaka. What are the drivers for their behavior? And what would motivate them to use something that I'm innovating, that I'm developing? And cost is certainly one thing. And the skill set needed to maintain and operate that process is another. What is the time horizon in terms of the way they think about their lives? If they're making $1.25 a day, they're not thinking about health issues 3 years from now, right? And so what would motivate them to invest in a toilet when the health benefit of that is longer term. So there are a lot of different issues that you think about, that I think about, and I speak to with a lot of my colleagues from other fields, social science scientists, public health researchers, and so forth, to try to understand a lot of those things. And I try to incorporate that into my thinking in terms of the technical innovation.
Thank you. Adam.
Just echoing your comments, I mean, involvement of the local stakeholders, I think, is key. Building capacity to make it sustainable, I think, is absolutely paramount. In doing so, you have to involve people in terms of the design, the execution, and the knowledge base around it to build it around it. That speaks not only to international, but especially First Nation communities around here. That's something we definitely have to address. It has to be tailored to that area. It has to be tailored to the culture of that area and how it works. It has to be, as everybody has already been saying, it has to be simplistic, has to be innovative, and it has to fit into the needs of that area.
Great. Irene, your perspective, please.
So for us as a technology company, obviously, we see the same issues, perhaps bigger in other regions when it comes to drinking water or sewage treatment or wastewater treatment. And but what we need to do if we continue being successful is innovating, continue on that innovation path to make sure that we have our second or third or fourth generation of the technology that we have already developed, but we got to make sure that we customize it in a sense that it works in other jurisdictions. And it's not just in the technology, as I mentioned in my presentation, it's how we operate these systems in other regions and how we maintain these systems in other regions. And I give you an example that when we put our system in one of the locations outside Canada, this is a large system, and we hired an operator after almost a year of contract now that they can locally take care of the system. You cannot turn off a sewage treatment system. You have to 24/7. You have to run it, and we had an operator who was paid to work during the night. And we realized that we were getting some alarms from our system, and then because all of our systems are equipped with telemetry and remote control. And when we checked with the operator and local people, we realized that the person who was responsible after 11 p.m., 12 a.m., turned off the system and went to bed. And when we asked the question, how, and you were paid to work here, he said, well, everyone is sleeping, it's time to sleep. And this is my quality of life. So those are the cultural issue, and we have to address that when we work with other regions. And therefore, you need to bring that innovation component so that you can remotely monitor your system. Otherwise, there's no sewage treatment system in the middle of the night for that community. So that's just an example.
Stefan, your perspective, please.
Okay. And in addition to the comments here about how the system has to be sustainable and maintainable after you leave, one thing that we've found is very important, because we have an unconventional technology. Civil engineers are very good at using what they've learned at school, and they will guide their clients to use the conventional tried and true method. We've needed to find clients that are entrepreneurial or innovative in order to embrace our type of solution. So that's another factor in addition to all of these other.
Has that been hard or easy?
It's difficult, and I think it's how you present it, and it has to be in the right sort of cultural environment, and cultural. It has to resonate with things that they need to accomplish. So, for example, in the Colombian. With the rainwater reuse, and I've showed some pictures of that, it was really a developer that wanted his development to stand out in some spectacular way in terms of wastewater reuse and using innovative technologies and foreign technologies. And it took a while to find the right person, but he really embraced the features of our technology, and it allowed him to do more.
That's interesting to hear. Okay, I'm going to ask individual questions of individual panelists before I open it to the floor. John, what does it take for a company to provide viable solutions for a global water these global water challenges that we're hearing about?
So my answer 30 some odd years ago was it's all in technology. Hang your hat on that, Bob's your uncle. 20 years at Xenon taught me it isn't all technology. It's that combination of team, value proposition, markets, competition. In other words, technology probably weighs in at, pick a number, 30%. You can't take something that doesn't work to market and succeed, but lots of second place technologies actually win the battle. And it really is about, the focus and deployment of technology solving what are real needs, not wants, and doing it in a way that, gets people excited. And that, we pushed up a very steep mountain. We were trying to take membranes, which everybody thought were these very delicate polymeric materials, and put them into a sewage plant. Okay, so everybody thought we were morons. Everybody who went to read the literature said membrane buyout, the Japanese have proven it doesn't work. You put membranes in sewage and your flux goes to zero. Well, we proved that you can keep flux from going to zero. And as more and more of that technology got tried and tested, and better sensors and controls came in, we could increase the performance of our membranes while decreasing the amount of aeration. The funny story was we used to have multiple basins of aeration. Every one of them, the blowers were going all the time. Our European companies were going crazy because energy costs there are 4 times what they are over here. And they said, why don't we try to cycle the aeration basin to basin to basin to basin? So instead of 5 blowers going all the time, we had 1 blower cycle from basin 1 to 2 to 3 to 4 to 5. So of course, all of the process engineers told us, ooh, the flux is going to go down. Well, the funny thing was, not only did we save 80% of the blowers, 80% of the energy, the flux actually went up. Okay, sometimes you get surprised, okay? But dare to be challenged, dare to be different. We had a lot of fun doing it.
Okay, speaking of different, Wilf, you talked about this combining financing with your technology. And you mentioned that Signina Capital, that you're partnering with them, offering $100 million municipal wastewater financing. How did you develop that program? Do you see it working here in Ontario? How is it different from other financing solutions out there? Can you just elaborate a bit more on that?
Okay, thanks, Brent. The one thing I didn't mention in my presentation was that using this type of 3-step collection and treatment system is actually a way to lower your treatment costs and your operating and maintenance costs. And it's quite a significant factor that it does get lowered by. And we've worked with the Swiss-German investors, Signina, over the last 3 or 4 years, and they become familiar with our technology and familiar with our way of working. And they have a fund that wants to invest in projects in Ontario with municipalities that have an A credit rating, and they will cover the complete costs of the design, install, and operating of the system. So it's been developed over probably 3 or 4 years as discussions with them. It's different than a triple P program where the municipality has to take on part of the debt and part of the risk. In this program, Clearford and its partners take on all the responsibility for the design and for the operation. And then the municipality or the town only pays when they get performance.
So do you see that working here in Ontario and
Well,
North America?
our target is to get full subscription of the $100 million over the next 12 to 15 months. And we've been in discussions with 3 or 4 different townships now. And there's an interest ever since our press release has come out. There's been an interest on that, and we're starting to get some calls. And what it has done, from an innovation point of view, it's taken away all the discussions about the technology, because now people are thinking about the solution, because they need a solution for their town. Their town can't grow because they're on septic systems, or they're in a water source protection area and they're starting to pollute their wells. And so they need a solution, and it's part technical, but a big part is finance. And so when they would enter into this type of program, it doesn't affect their credit rating, they don't have to take on more debt, and there's a ceiling to the amount of debt that municipalities can take. So that it does seem to be of interest to several that we've spoken to.
Well, it's fascinating, and I'd like to open the floor to questions. Don't be shy. Yeah. There's mics on both aisles here.
Hello. Thank you. I've enjoyed the discussion. My question involves the regulatory environment more local, like in Ontario. Once you're beyond the reach, if you run a company and you're beyond the reach of a municipal sewage system, you have to deal with the MOE, which can be painful and long, and for most people involves consultants, because you don't have the skills that you need. I guess I'm thinking Nuterra has a rental program, and it comes with its own MOE license ready to go. Is there any sort of fast track for some of these solutions? So the MOE would see it, they'd say, okay, it's a Nuterra XYZ system, and you would sort of go through the process much quicker. It would help you, it'd help the user. I just didn't know if there's anything, if anyone's worked with the MOE at that level.
Irene, I can take a stab at that, but Irene, do you want to?
Well, I think MOE is working on their modernization of approval process. The hope is it moves faster and we see more improvement in that area, but it's not there yet 100%. And yes, to echo what you said, for sure there are a lot of issues with the approval process, and it takes a long time for some of these projects to, especially for a small, medium-sized company, we need to move fast, right? And then and the client needs the system. So I think one of the issues that we have in a province like Ontario, in order to be more successful, we really need to, and there's a lot of work is happening behind the scene through associations and many different groups and WaterTap and other organizations to bring government and industry together and always listen to some of these challenges. Whether we benefit from any particular relationship to fast track, sometimes knowing people would help when they trust your system and they have seen many installations, but you still have to go through that process.
So what I would add to that, thanks Irene, WaterTap has a regulatory working group, and it's a committee of WaterTap that has been looking at the regulatory landscape, and right now it's focused on mapping that, working with Ministry of the Environment and Climate Change and other ministries such as Municipal Affairs and Housing that have regulations that affect the water sector, and helping to communicate them better. So I think language like fast track probably has the wrong expectations of in that the Ministry of the Environment and Climate Change is not going to jeopardize human health or the environment or put any of those two at risk. But they do have programs in place where essentially those liabilities and risks are mitigated, and that would be their pilot program. So I have worked with several companies that have gone through pilot programs, and essentially it's based on the idea of redundancy. If you have a technology and you have full redundancy, then there isn't really any additional risk to the environment or human health. And there are various facilities around the province that can do those types of studies, like Southern Ontario Water Consortium facilities. Some of the colleges and universities have similar facilities. So that's probably the best route to get those in. In terms of full-scale non-pilot approvals, yeah, that's a different question, and it can be very frustrating for businesses to know when is enough in order to be fully commercialized, get out there. And we're trying to work with the government to help communicate and understand when enough information, enough data is enough, so that everybody's comfortable with the new technology. It's a very common question, so thank you for asking that. How are we doing for time? We're good? 1 minute? It says 1 minute. What is that? I don't know what that means, but 1 minute till I have to stop talking? Yes. Okay. So who wants to ask one more question? Yes, please.
My question relates to developing countries. I see a good example where you built a system in a developed country, but what are the barriers in developing countries in very broad acceptance of technologies for wastewater treatment? Because let's face it, regulations don't always mean much to a lot of the bulk of the people, and people can't often afford to pay. So how do you overcome those barriers, and what are other barriers that might exist?
So can I suggest maybe our three middle panelists who didn't get the last questions, you've all had experience in the developing world. So Dr. Chan, I'll start with you, and then
Okay.
ask Adam and Irene.
Sure. I'm not at the stage of having implemented anything yet, but I would say, from my perspective, you build that cost constraint into your technological development as part of your specs from the very beginning, by understanding who the users are, what their financial constraints are. With our toilet project, for example, it's a very ambitious cost target, which fits the end user, and I think we're going to get close to meeting it. But you develop the technology with that goal in mind.
Great. Thanks, Adam. Quick word.
I would say definitely a local partnership and knowing somebody on the ground that you can work with, that you can trust, I think is a big part of it. Depending on where you go, you have to protect your IP, you have to protect your design, but you also want it to be effective. It's your name on that system that people live and die by. So I think it's critical that it's designed right with the local population in a sustainable way, which is sort of a general answer, but that's it.
Irene?
I think the key to have in mind is the cultural and social structure of any region that you want to work with. And as I mentioned before, customization of the system, the cost always matters in other regions. So once the market is studied really well, and as you mentioned, the involvement of local representatives make a huge difference, I think it can be a lot more successful. Language can be a barrier, because you mentioned about the barriers, social issues, cultural issues, as I gave you an example. And definitely the right technology and the right solution for the problems that they have, but necessarily what we have in North America may not work in other jurisdictions.
I was particularly referring to the installation in Zambia that you showed, which is very much a developing country, and we have a membrane bioreactor, so there are some drivers, and you were able to convince that community to spend the kind of money that probably it took.
But I have to add something here. As much as probably that sophisticated system wouldn't have worked if we wanted to work with a small community, it was successful because it was with a mining company. So the end user was the mining community, and there is another side to innovation for a lot of mining companies when they work in other parts of the world. They have to move communities, they have to provide them with home and infrastructure, water and wastewater being one of them, so that they can move forward with the project. And that was an example of one of those projects.
Okay. Thanks, Irene. I think we're out of time, so I'm going to wrap up questions and comments. Thank you to the panelists for your insights. I'm going to hand it back over to Carol to wrap things up.
I'd really like to thank our five panelists, Wilf, Irene, Adam, Yuling, and John, for a very interesting discussion today. And I'd also like to thank our moderator, Brent, who did a fine job of asking questions and keeping everybody in line.